Hello, listeners. Welcome to a new episode of the Unlocking the Energy Trilemma podcast with our hosts Ravi Krishnan from the USA and Jose A. Martinez, JAM, from Europe. Today, Ravi and JAM speak with James Macnaghten, the CEO of Caldera and a Cambridge University-trained engineer with a wide experience in energy research and development. He has been inventor on a wide number of thermal energy storage patents. We talk today about decarbonizing industrial heat, so James is a perfect guest. Ravi, JAM, over to you.
Thank you, Ava, and welcome, James, to the Unlocking the Energy Trilemma podcast.
Good morning, Jose. Thank you very much for having me on this.
As we do with all our guest speakers, I ask you to share some facts or figures with our audience around the energy trilemma, and particularly the topic we are speaking today, the industrial heat. What do you want to say?
Look, the world has made amazing progress towards decarbonizing electricity. But industrial heat is a subject that gets very little mention. And what nobody really grasps is the scale of it. So if you took all the energy used for electricity in that world and you double that figure, that is the amount of energy we use for heating in industrial process. And it's everything from steel making, cement, down to brewing and distilling. But the key point is that half of all that industrial heat is under 200 degrees Celsius. So it's really easy to tackle today with existing technologies.
Excellent. So there are many technologies out there to enable the energy transition and also decarbonize. In your view, what are some of the more promising technologies that can pave way for a significant reduction in carbon emissions?
So I always start from the generation side, which is you need low carbon generation. And for me, it's all wind and it's all solar. My personal view is nuclear is too expensive and it takes too long to build. And until that changes, I don't see it being part of the solution. We haven't got the time. But wind and solar, so the first thing is you want to have excess generation, because the whole point is we overinstall, you end up with excess generation, and then other technologies potentially come into play. So that would be the first one, is we need to have more and more renewable generation. The grids are struggling to keep up. So if you're feeding all the electricity through the grids, we need better grids. And then when it comes to a lot of, particularly I'll talk about industrial processes, but more generally, you need to electrify everything in my view. So we want to electrify heating, we want to electrify transport, and how you do this electrification can have a big impact on how much you have to spend on your grid and how much generation you have. And we've got many of the answers, but we don't have them all. And to me, it's going to evolve over the next 10 or 15 years. But I would, if you were to say anything, I think the solution is to electrify everything.
You've mentioned the grid. I think costs and delays of grid connection upgrades are increasing. At the same time, some states or countries such as California or Italy are moving their regulation to push rooftop solar out of the grid and remain as a self-consumption solution. What do you think about behind the meter solar as part of the future? Is something which could be pivotal or not?
I think there are two sides to it. One of them is I think the current grid rules and pricing incentivize everybody to put behind the meter solar in. So you have most of the cost of your electricity bill is not the generation. It's grid charges, it's charges for building solar farms 10 years ago, for building wind farms 10 years ago. So in the UK, if you put a unit of electricity into the grid, move it 100 meters up the line and take it out, they will add 10p onto the cost of it. Now, if you own a factory and you build a big solar farm and connect it straight to your factory, you pay none of those charges. So I think the current charging structure massively incentivizes everybody that has space and energy to build behind the meter either solar or wind farms, because it's so much cheaper. And where it's become particularly relevant is that often the price of electricity is cheaper than the price you're paying for something like natural gas. So at this point, you don't care whether you use the electricity from your solar farm for heating or for electricity. It saves you money, and it's also almost always helping you cut your carbon emissions.
So in that same argument, what strategies do you see as being necessary to address the intermittency of the solar energy in industrial applications, especially for maintaining a consistent energy supply?
So we see hybridization. This is a journey. This is a roadmap we're going to do over 10, 20, 30 years. To me, the most logical, safe option is you've got giant gas boilers if it's a factory for generating steam, but you hybridize. So you put in electric connections and that will only run when there's too much electricity on the grid, so you're not stressing the grid. But you can effectively swap fuels between electric and gas. And what happens is as you build more renewables, you run the electric more and the gas less and less. So to first of all, I think hybridization is a really key strategy, because if you don't have hybridization, you then have to provide electric storage to cover these periods when it's not windy and it's not sunny, and that's really expensive. So to me, it's a much smarter strategy to try and hybridize. Now, once you do put electric in, you've now can start to look at the processes. And I would say, obviously, Caldera, for which I'm the CEO of, we're interested in electric heating and thermal storage, but that's just one route on the journey. If I look at a factory and they can put, for example, a heat pump in, we'd say go and put a heat pump. I see heat pumps being part of the solution. I see energy efficiency. I walk into factories every day and there are pipes that have just got no insulation on carrying steam at 200 degrees Celsius. And the plant manager goes, yeah, I know, I need to do that. And what we see is there are lots of opportunities, because historically gas was incredibly cheap and it didn't really make any sense to worry about energy efficiency. So I think there are multiple approaches, from electrification to energy efficiency to switching to heat pumps, all of which are going to vary depending on what the factory is, the age, the type of process, everything like this. But I generally don't see it being a roadblock. I think the thing that is the roadblock is if you say to that factory, you have to go all electric today, because they cannot possibly afford the bill.
All right. So you're talking more in terms of reducing carbon intensity as opposed to achieving a net zero goal within a given period of time. As you said, it's a journey. So you actually, with the hybrid approach, you minimize your carbon intensity over time by blending it with perhaps natural gas or some other fuels. Correct?
Exactly. And the reason is because we have a limited amount of capital we can spend. We want to do this quickly. We can't afford to be dumb about how we use our money. And to me, it's always a case of the cheapest, fastest solution to getting to low carbon. And sometimes that isn't that. I sometimes have arguments with people who are quite very slightly religious in their belief that we need to hit. And I personally think we will need gas and coal and oil for a very long period of time, but I don't think we're going to need a lot of it. So I'd much rather cut 50, 60, just get rid of 50, 60% of our emissions quickly without necessarily worrying about how I do the last 30 or 40, because that's much better for the planet and it's the only way we'll get there. But I also have faith in technology developing, which is the other reason I think you don't need to rush for this end solution. So the example I like to give is 10 years ago, in all practical cases, you couldn't buy an electric car. 1 in 5 cars sold today are electric. So I don't necessarily need to know what the technology is going to be in 10 years' time. I can just be fairly confident it will be a lot better. So trying to make decisions for 2050 to me seems absolutely daft. It makes no sense at all. We should be making decisions for the next 5 and 10 years, because we know what our technology options are now. We have no idea what they'll be in 10 years' time.
You've mentioned energy efficiency, you've mentioned capital, and 1/3 of the energy consumed in process heating is lost as waste heat. So there is room for improvement in energy efficiency. And in the other hand, capital is very important. And we can say that, you have mentioned at the very beginning, the industry applications depend on the temperature of the heat required, and you can divide below 200, something between 200 and 400, and above 400. My questions are, how can you address those different ranges of temperature and applications, and where should we put the focus to decarbonize the system, the low-hanging fruit?
Everything under 500 Celsius is low-hanging fruit. We have electric heating that is perfectly capable of that today. Between about 500 and 1,000, There are some sectors that can be tackled, but it's starting to get more expensive. I see pilot plants for making cement using electric calcining as a good example. Above about 900 Celsius, electric elements get very expensive and very specialized. And so if I go up in temperature, glass making, we're close to being able to electrify glass making. Cement making, no at the moment, but it could come. And then you go to steel making, and fundamentally, I would say if I wanted to decarbonize it, it's the one application I would use hydrogen for in a sort of process setting. But I come back to the early one, which is I don't understand why we'd spend any time at all on hard to decarbonize sections when we're not doing the easy to decarbonize. And it's absolutely massive. So we could spend all of our money for the next 10 years on the easy to decarbonize, and we still won't have tackled half of it. So to me, it's a misallocation of resources, worrying about these difficult ones, because that's not what we should be doing today.
And why is it happening? Why do we have the hype on hydrogen and spending billions of euros or pounds or dollars in that?
So I personally believe there is a certain amount of government and public sector sort of capture by the oil and gas companies who want us to have a reason to exist, and hydrogen, I believe, has been positioned as a easy option for replacing natural gas. I think personally it has also cynically been used to delay decarbonisation, and if you say to an MP, no, you don't need to take out your gas boiler, we'll do a hydrogen ready one, they go, oh, that's great. And yes, and we employ 200 people or 500 people in your area. They're not technical, and I think some of it is very deliberate, and I feel very angry that I think we have wasted a number of years with hydrogen being positioned by people who know perfectly well it doesn't work and it won't do what they say it will for their own effectively financial gain.
Yeah, you brought up hydrogen in the context of steel making, and yes. Can you give us throw some light on that as to why you think hydrogen is particularly more effective in steel making as a fuel source than something else?
So I don't know of any heating elements that will last at 1500 degrees Celsius. So it depends on which process. So if you're looking at a blast furnace, you need heat, and also I think you need an oxidizer in there. So there's two things going on when you normally feed natural gas in to a blast furnace. Electric arc furnace, it's already been done. That's easy. But anything that you want to generate heat at these sort of high temperatures, I think, has got to be a chemical molecule. Hydrogen is the best one to make. It's more efficient than, for example, trying to make methane in a chemical process. It's got the least amount of downsides to it, and I don't know how you can heat something at 1500 Celsius otherwise. Now, there are companies like, I think, Boston Metal, who are looking at running a chemical process to effectively reduce iron oxide to iron, which might mean you don't need to go to these temperatures. So I would say you want hydrogen you could use it for steel making, use it for ammonia production, and broadly all of the chemical processes that we use hydrogen for today, where you make hydrogen from natural gas on chemical plants, we're going to need the hydrogen to be used in that application as well. So if you took the current hydrogen, that's still a lot of hydrogen, but it's not going to solve any of these other problems.
And what can you tell us about energy efficiency? We've mentioned before there is a lot to do there, and it's like the electric car and gas cars.
So the electric car pretty much reduces primary energy consumption by a factor of 3. So it's a great solution. So it immediately reduces the amount of energy you need. Heat pumps are a great piece of technology if used in a sensible way. And I think my general view is, if you're building anything new, you should be able to integrate heat pumps into it. And this includes industrial processes, especially if they're at the right sort of temperature range. It's very hard to fit them into old buildings, or it's harder to fit them into old buildings, and it's hard to fit them into old factories. I see as factories get upgraded, replaced, they come to the end of their life, they will be replaced. And a good example would be distilling. So when you distill alcohol, you boil it at one temperature, so the alcohol comes off, and you condense it at a very close temperature. And that's a very good example where you can use heat pumps to recover the heat and recycle it. So I personally think there's huge opportunities for reducing energy demand through things like heat pumps. I also think when people value energy more, they do all of the things they should have done around insulation, and that it becomes, suddenly you get an economic payback. So you can go and say, we need to re-insulate all of our, high temperature steam pipes. You can afford to do it because you're losing too much energy. So I'm much more positive that a lot of the decarbonisation will actually come from just reducing demand, but not in a way that actually changes what people can produce.
Mm-hmm. So in regions like Netherlands, I'm sure you're following this.
Yes.
There's a successful heat pump adoption program. And then some people have argued that it has led to concerns about grid reliability. And I know you talked about hybrid systems where gas is used during peak demand periods to avoid overloading the grid. What lessons can you actually learn from Netherlands as it relates to other markets in Europe to promote heat pumps?
So I suppose it's a combination. We normally transmit much more energy around our countries by gas than by electricity. We had a huge building program in the 50s and the 60s when most of Western Europe built out their high voltage grids, and it went really well, and actually we overbuilt our grids. Since then, I would say in the majority of countries, I can definitely say for the UK, we have underinvested in our grids. We're going to need a lot more cables, we're going to need a lot more transformers, and because much more of our power is going to be transmitted via the wires. And I would say, I suspect in most countries, we're not there. There is a shortage of transformers. I don't know if you hear this, sort of 9 months to several years for a large sort of medium to high voltage transformer. It's causing lots of problems. And I think we're going to have to spend a lot of money on it, but I actually don't think it's going to be fixed anytime soon, because every time we upgrade the grid, we're going to add more electric vehicles, we're going to add more heat pumps, and we're going to add more renewables. So I see this grid strain point running for probably a decade or two without any worries at all, because I think every time we fix it, we're going to want to do more with the grid. It's just because we're going to electrify everything. So we're suddenly putting twice as much or 3 times as much power through the grid. It tells you you're going to need 2 or 3 times as many cables, transformers, everything.
You are opening a very interesting door. I'm not sure if you are neutral as CEO of Caldera because you do thermal energy storage, but if we're increasing the electrification of applications and so on, what should we prefer, to store thermal energy or to store electricity in a battery or something like that?
Okay, so I'm going to give you a third option that I feel you've missed. So I think when you, first of all, if you have electricity, you always want to use it if you can. So that seems to be easy. There's no requirement to store it. If you then have a surplus, which is inevitable when you add renewables to the grid, and it's actually part of a well-designed grid, you should have periods of surplus generation. You actually have 2 choices at this point, maybe even 3. One is storage battery. One of them is to move something like you were going to charge your electric vehicle at night and you now charge it at the right time. You could also just substitute it, and this is why industry is really interesting, because if you go for direct electric heating, if you imagine that you have electric heating the industry uses enough energy that it can absorb everything you generate as a surplus, then you don't need storage. But what's more important is you could do this for days and weeks without. So people talk about storage, but the problem with storage is it fills up. If you have a windy period for 2 days and your storage lasts for 4 hours, like your battery, after 4 hours it's full, there's nothing you can do. And the reason that heating is so interesting is because companies use it 24 hours a day, 365 days a year, and it allows you to use energy for very long periods of time without actually having to worry about exceeding the amount they can absorb. So I describe it slightly different, which is thermal storage comes at the end of all of that, because if you can use it in real time, you can use it in real time. You could have put it in an electric battery. If you can't do that, what else am I going to do? I'm going to store it later to use it as heat. So I say heat is the lowest value usage, but it's normally the value of natural gas. So if you imagine natural gas is 1/3 of the price of electricity, that's as long as the electricity is cheaper than the price of natural gas, industry will start to use it for heating for long periods of time.
So finally, from my side, it sounds like you are supportive of decentralized energy solutions. And what do you see as some of the biggest challenges in achieving the decarbonization goal in a phased manner, focusing on minimizing carbon intensity and keeping prices low, as opposed to trying to achieve a certain target regardless of the cost of such compliance? What do you see as some of the biggest challenges?
Grid pricing. And to give you an example, again, I use the UK because I know it best. If maybe it costs me, a good example, every unit, even if the wholesale price, so the price of electricity is zero because we've got excess generation, if I wanted to buy it, I have to pay 10p in grid charges. So immediately it's now more expensive than natural gas. And these grid charges do not relate to the fact that I want to use energy at that point. They're to pay for the grid over the whole year. And you end up with this bizarre situation, which is the electricity price is low, and effectively it's a tax that discourages you from using electricity when there's surplus. But actually, we end up, because it's a fixed price, it ends up subsidizing electricity when it's expensive. So as an example, you could put those charges on as a percentage of the wholesale price. So when the wholesale price is zero, I can buy it for almost zero. And when the wholesale price is expensive, it makes it more expensive. So from an economics point of view, the current charging structure makes no sense because it subsidizes peak demand and it penalizes off-peak demand.
James, super interesting conversation, and I would like to conclude the conversation with the same question we asked to all our guests. If you had a magic wand and you can unlock the energy trilemma, what would you do?
I think I've probably pretty much covered it already, but I would get everybody to focus on all of the easy achievable goals in the next 5 years and stop being distracted by what happens in 2040.
Not easy with all the politicians and marketing staff we have around the energy sector, so the magic wand must be a big one.
Jose, I would agree. It's got to be an enormous magic wand, and I like to describe myself as optimistic but not hopeful. And Ravi, it's been very nice to talk to you as well.
Okay, James,
Yes, absolutely.
thank
Thanks
you
for
very
talking to me,
much,
James. Yeah.
and we'll follow you in the distance. Thank you.
Take care. Thank you. Goodbye.
We hope you liked this conversation. Follow us on LinkedIn or subscribe for free to the podcast on the platform of your choice, Spotify, Amazon, YouTube, or Apple. Because in the next episode, Ravi and JAM will speak with another industry expert who will help us to unlock the energy trilemma.